So hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. The problem says ZigZag Traversal of tree. So it's a typical tree traversal but in a zigzag fashion, that's what I believe. uh, it says given a root of a binary tree, you have to find a zigzag level order traversal of a binary tree. In a zigzag traversal, we traverse the nodes from left to right for odd number of levels and from right to left for even number of levels. So for right to left to the even number of levels, that means if we traverse one uh, level 1, then we should have it in the left to right fashion, but in the level 2 we should have right to left, that means this is reverse. And again this is level 3, which means it would be odd level, and from odd level it should be left to right. That means if we are traversing it to 1, should be the traversal result. Thereafter we should have traversal of level 2 as 3 2, because we should traverse in the reverse order. And next for level 3 we should have a traversal in a left to right, so that is 4 5 6 and 7. So 1 3 2 4 5 6 7, 1 3 2 4 5 6 7, that is how it should go. Same goes for such kind of tree. It was a complete tree, and hence we went ahead with this fashion. We should also incorporate nulls. Whenever we say null, we should not print anything. So here in this case of example 2, it's level 1, so left to right 7, then right to left 7 9, 7 9 we see here, then left to right 8 8 6, 8 8 6, then right to left 9 and 10, 9 and 10. Here we go. So this is how the traversal would be. We are pretty sure how it's going to be. Let's see how we can do it, or how we can explain ourselves in code. One thing for sure is we wanted to have a reverse based upon level. So based on level, if we are having a reverse, then we need to for sure go ahead and have a level order traversal, because this would give us a more command and control over the levels. You can obviously go ahead and do DFS, but that would require more amount of work to do. You need to incorporate what level I am upon and how I wanted to traverse. That would be based upon the even and odd parity of the level. So for justifying left to right or right to left, that's why we are going ahead with the level order traversal. Not only that, we need to keep track of each level. So we need to keep track of each level, what level I have completed upon and what not. So this is pretty simple. We know how to do a level order traversal, but we need to check upon how we can keep a track on each level. So you see, each level completes when we finish till the last. So if you have finished with last node as 3, we have finished the level. If we have finished with the last node 1, then we finish level. So what I mean is, if I have a symbol, let's say 0 or 5, I cannot enter Greek letters out, let's say n post 1, then I am pretty much sure that this level is completed. 2 3 and then n, I'm pretty much sure that this level is completed. Then we have next level as level 3, 4 4 5 6 7, and then if I insert n, I know that this level is pretty much completed. So what this n would do, n is nothing but I would tell here, I would go ahead and tell here as n should be indicator null. This would be something as a flag which we would be keeping track. Whenever we hit null, we are sure that we hit a level. Now when we hit null, we are sure we hit level 1 as completed, and simultaneously we need to populate null again in order to take care. So for 1 the childrens are 2 3, but for null we need to enter null again, just to indicate that this would be end of parent and hence there are no further childs. Since there are no further childs, this level is potentially marked as complete. Makes sense? So that means null I'll end at some point as like null indicates end of level if seen null level is complete. If seen null, no further elements beyond this node, so child should also be finished adding siblings up. So you know siblings, 2 and 3 are siblings, 4 and 5 are siblings, 4 and 6 are siblings, which are upon the same level. These are siblings based on different parent, but these are still siblings. You can call it as cousins and all. I'm not getting deep into this terminologies, but the gist is when we encounter null, we need to again put null. If seen null, so if seen null, enter null. So this should pretty much suffice the algorithm, and ultimately this is a no-brainer that keep a tracker based upon reverse print or not. So now with these things in mind, we can get started. Level order traversal, you know how we do it. It's pretty much done with the help of q with integer. Sorry, I'm not taking integer, it's node, and we will take it as q new linked list. But prior to that, let's take this return type, because we need to return this array list, and we will store a result in this fashion. And yeah, for indication of level, I'll take list of integer level new. I'll take a linked list. Anyways, cool. We have a result. We have level, which would indicate that this level, that level. We have a queue for processing, and now we will offer root to our queue. And remember, we will also offer a null, because we need to understand that 1 itself is root and nothing is beyond this node. That means this level is completed with root itself. So while I'm seeing queue is not empty, whenever I'm seeing queue is not empty, let's process it. And however we process it, I'll take a current node, current as q dot poll, and if I'm seeing that current is equal to null, you know the drill that we hit a level. I'll tell you what we will do over here to do implement, but prior to that we will do one thing, that if we see we need to process it, right? We need to add it in the level, because this is currently counting upon the level. So level dot add current dot data, and now if I am seeing that if current dot left is not equal to null, I'll go ahead and add q dot offer current dot left, and same goes for the right. Now let's implement this. Let's remove the to do, because we are going to implement this. Now we hit a level. What we wanted to do, we wanted to check whether we should go for a reverse or not. So if is reverse, then we wanted to reverse it. Is reverse should be a boolean. Boolean is reverse, which initially should be false because we are not going to reverse the first, what do you say, first level. That's the reason. And if you wanted to reverse it, we'll do collection dot reverse derivative method for reversing a level. And now we are going to reverse it, so let's be prepared and add everything which we have from the level into the result dot add all from the level. And not only this, I'll do one thing, I'll post this, I'll clear up the level dot clear, because this level is cleared, this level is already stored, I don't need this level again. I wanted to clear and I wanted to look for the next level, which should be 4, 5, 6 or 3, 2 beyond this one. If one is clear, I would make room for 3, 2. And ultimately, is reverse should be toggled. So if it was false, it should be true. If it should be true, it would be false. And now a check. Now see, we are adding null at every point, right? So if we see or if we encounter a null, we need to again backfill null. That makes sense. But what if we are genuinely at the end of the tree, no more nodes, and we hit null? We will go ahead and again encounter null, and we will fill again null, because that's our logic is. If see null, enter null, or offer null to queue. So if I'm seeing null, I'm offering null again. If I'm seeing null, I'm offering null again. You see the pattern, this would never end. So I need to have a break somewhere. I need to have it break within if queue is empty. I don't want to fill null again, so I'm going to break this one, right? Check for the tree completion. So I'm going to check for the tree completion. If it is good, then good, I'm good with it. Else I'll do add queue.offer null, because this would again indicate the end of next level, that I'm done with this level, go ahead to the next level, and ultimately continue, because I don't want it to go beyond this, because current, you know that current is null, and if I do current.data, it would give a null pointer error. I wanted to continue it from this point to the next one. So far so good. Ultimately what I'll do is return result, and that should be good. That's what I'm looking for. I have a queue, I have offered queue with root and the null specification or the flag, processing one by one each, checking if current is null. Yes, if it is, we hit a level and check for the reverse it, add all, clear the level, reverse toggle it, and next if queue is empty. Yeah, so far so good, looks good. And let me compile it for any compiler errors. It's not collection, it's collections, my bad. Okay, cool. A sample test case has been passed. Let's submit this for checking the rest of the test cases. And you see, we are done with this problem. Thanks for the coin. And we have completed. This was a typical case of level order traversal, but a quite a twist where we wanted to keep a track of each level. Reversing was not a big challenge, as you asked me. It was just an if-else case, but keeping a track of level was a good one. One might go ahead and say, hey Aniket, why don't you go ahead and check it with the help of counter. So initially, if you had root, that means only one node, so you can run a loop to check whether for one node or for n amount of nodes, or let's say n nodes, I'll run a counter and I'll understand that hey, I am within this loop, or this is my level, and once I'm getting that level, reverse it or not reverse it. That's a good one. For that you need to have an additional loop. That's not what I'm looking for, and it was a good simple solution. You can go ahead and implement that. The time complexity would still be O of n, because you are not going ahead and iterating multiple times. Even for this iteration you would iterate only once a node for while loop, and for inner loop you will still, each node would be still iterated only once, not every other time. So on, for every, for each node, if you go with count method, count approach, each node will execute it in 2 loops, and that would be O of n plus O of n, which would be O of n anyways. That's not a big deal. So O of n, and that's the case. You can go ahead and implement it. That would be a good way, and that's all for it. Thank you.